Last day of classes till finals.
It's the final countdown.
Where's all the enthusiasm? The semester's over. Except for it's not because we're still
It's never over. Life is a giant circle.
Far
You
from
keep
over.
going.
Ready, shorty?
Where y'all going?
E&M.
Oh boy.
Let's go. We have class in 1 minute. We gonna go watch Dillard give his senior thesis. Dude, what's his thesis even on again? It's like late.
He's doing a frequency adjuster for lasers. For some technical term, but that's basically what it is.
Yeah, something to like get rid of vibrations and stuff to make sure that the frequency stays constant.
Well, it doesn't get rid of the vibrations. It tells it if the frequency has gone off by a certain amount, and then it says, "Oh, this is too extreme of a difference. You have to fix it," and so it'll fix it for you.
Oh yeah, that's what the prescaler's for. I guess we're gonna find out what it's all about. There he is. Are you gonna wow us today with some science?
Yes.
You're a candy cane.
Investigating a beat lock circuit for frequency offset locking the laser. Idea of a beat lock. So the idea of a beat lock, what we're trying to do here is we're trying to compare the beat frequency from two lasers and send them into a photodiode along with a frequency generated laser that we're supposed to be locking our unstable laser to. The reason for this is that what we need to do is like, once we have this laser frequency and we have it stabilized, this gives scientists inside of the lab a little bit more explanation to like why they would understand, the spectroscopy of cold atoms or, the structure of atoms in that extent. The reason that we try to stabilize these lasers, a lot of different things that make lasers unstable. Like the best things that I actually learned from this, I actually learned how to solder, which I believe will help me in my job too. We learned a lot about circuits that I never knew before. It was like advanced circuitry that I never knew before. And there was a better understanding of lab equipment. And that done a lot for me, so that's about all I have.
Can you hurry up already so we can study for E&M?
Oh my god. I'm getting there.
Oh shit. What's up, squad?
Yo.
Vice President?
Am I still vice president?
Are you still Vice President or did you quit?
I'm asking.
Yeah, you're still, you're,
Yo, man.
I don't want no responsibilities till next semester. Okay?
So guys, I'm an official member of the Honor Society.
Hey.
So,
see
an
that?
amethyst.
Yeah, honor cords.
Oh, wait, hang on. Let me see. It's not a
Yo, relax. I also got the
You guys got cords?
Well, I bought them.
Yeah, I took pictures of you and Amethyst signing the sacred book
Yeah.
of
We
physics,
get
I know.
this,
I was like,
and then I bought honor.
which is really just my old textbook, and I just hold it
did you get my
sacred.
universe tie? My beautiful universe tie.
$80 like all the other ones.
I'm going to walk, so if anybody wants to come.
That's internship money right
I'm
there.
waiting for her to print off the questions for E&M, and then we're gonna go study.
Go study.
So we got that final tomorrow.
See y'all.
So you got that after.
How many is it, roughly? How many?
29 minus 14%.
Oh.
15.
So you just like, it was like.
I mean questions. Is it 15 questions?
I bought this a couple months ago.
That's not too bad.
That's fine.
That's dog. I gotta document all this stuff.
You get some good footage.
I mean, I got all of David's thing,
Sign a book too.
and then the other people weren't comfortable with it.
Sign a book with like all the people that have ever been inducted into Sigma Pi Sigma.
Just got out of the final for E&M. Last exam ever for E&M until grad school. But that was tough. That was kind of hard. It was all, pretty much all special relativity. A lot of questions to answer. And then some of the questions were really cool. There were like questions like, show that Maxwell's equations satisfy the wave equations for electromagnetism. Just a bunch of derivation questions, and then one or two that were just kind of out there. Like, we don't really do too much with electric fields and matter. There's one of those on there. Overall, it was really fair, but I'm just exhausted now, and I have to study for my stat mech exam. I have that final tomorrow. And we just had a midterm in that class like 3 days ago, but we got it back, got a 96. But yeah, now I got my stat mech final tomorrow to study for. Kelly and I just got out of our thermal and stat mech final. That sucked. Oh, I shouldn't say the F word, sorry. We had our thermal and statistical mechanics final today. Well, really, it was all statistical mechanics, and that was brutal. That sucked. Yeah. Spent 3 hours on it, and I almost finished 4 problems. We only had to do 4, so that was good, but man, that was tough. But yeah, so I got out of the thermal final, and then I went to check to see if any other final grades have been posted. And I got an A in E&M Part 2, which is nice. So all that's left now is just start studying for partial differential equations. I'm not worried about that exam. That class is really straightforward. I mean, it seems like the most applicable math that I've been in a way, like the most intuitive, because you can't solve a partial differential equation like an ODE. Like, if you take an ordinary differential equations, you can be given one and they'll say solve it. And you can, or hopefully you can. With partial differential equations, you need boundary conditions and or initial conditions, or else you can't just solve it. It just doesn't work that way. So since you need boundary and initial conditions to solve the problem, it almost seems like a physics problem, because it's like you have to think like what function would satisfy these boundary conditions and initial conditions, and if you can kind of convert that into being like, what would act like this? What's derivative at evaluated at 0 is equal to the regular function evaluated at 0, like those being your initial conditions or something like that. So partial differential equations is not like a very difficult class. Stat mech, statistical mechanics, is not very easy. I don't know. I should still be able to get an A in statistical mechanics. I'll be really disappointed if I don't get one. But I'm glad I got an A in E&M. That's one checked off. Now I just gotta wait to hear back from experimental physics, statistical mechanics, and then partial differential equations, and then the semester will be done. And I'm sure one of my professors will be happy once it's done, because then I can start actually working on my my project for my internship. So basically the way, I'll probably have to make a whole video on what this internship is about, and hopefully they'll let me record like things that I do. So yeah, I'll be working on this internship. I'll be working on my senior thesis a little bit, because my advisor for my senior thesis, who is also my E&M professor, sent me this review article on everything, and it's pretty heavy actually. It's got like quantum electrodynamics in there. I started reading it and started seeing reference to like spinors, and everything's in like tensor notation, and it's cool. It's really theoretical, so it's right up my alley. Yeah, it'll be really cool to actually finish up the semester, start learning how to code properly, because I've got to learn Python and Fortran, and just start doing something more real. So I'm doing my lab report on the Frank Hertz experiment, which basically showed that energy is quantized and discrete. You can't just go up an arbitrary amount of energy. And so what they did was they took a vacuum tube of mercury and they accelerated electrons through that tube. and they had a collector on the other side of the vacuum tube that would collect the electrons, and it would just read it as like current versus voltage. So the more electrons got through, the more current it read. What they found was at certain voltages that would correspond to accelerating the electrons to have a certain amount of kinetic energy. At discrete amounts of kinetic energy that those electrons would have, it would bump the mercury atoms up in energy level. So those electrons would drop in energy due to conservation of energy and momentum, and a lot of them wouldn't reach the end of the vacuum tube because of that. So what that would correspond to was a drop in current. So Gustav Hertz and James Frank realized that this only happened for certain voltages that corresponded to certain energies. So we did an experiment that was exactly the same, except for we used neon because neon's like normally in gas and it's chemically inert, so it's convenient. And I'm not particularly good at experimental physics, so what I decided to do was try to prove it mathematically. And in my mind, I was like, okay, they wanted to test the Schrödinger equation, right? Because that one, if you guys have had partial differential equations, shows that there are specific eigenvalues that correspond to a specific eigenfunction that satisfy the Hamiltonian. So I was like, this is what they were testing. And so what I did was I solved the Schrödinger equation for basically a three-dimensional square well, so time independent. I went through all of that and the derivation, typed it out on LaTeX, and then I found out that the Schrödinger equation, or rather the Frank-Hertz experiment, predates the Schrödinger equation. So they weren't testing it, they were testing someone else's theory, and I just basically proved it using, I guess, an ad hoc or a post hoc theory. So, I mean, I'm going to keep it in there because it took me a little while to do, but I'm kind of mad that it didn't come before. But it's a pretty cool experiment, and it's pretty cool to see how you can have experiment and theory agreeing on something so weird about nature that it's picky about what energies things can jump up with. Here's what it looks like. I need to study more for PDEs than I thought I did, because, or not like the earlier stuff, because it's so built on from the previous stuff, but things along the lines of like Bessel functions and just three-dimensional partial differential equations in general are just really tedious. So, for example, right now I solved the wave equation for a vibrating circular membrane, and it's just there's a lot of steps to it, and it's not necessarily difficult steps. That it's very, the method you use is the same method you use every time for a circular membrane, so it's just something that I need to practice more. But yeah, I just know now that I need to put more time into it tomorrow and Monday before my exam, before I'll be completely ready. My mom and I are about to go out to dinner to celebrate how successful of a semester it's been.
Hey, hey!
She keeps me eating good.
Going out to celebrate.
Where are we going?
Aberdeen Steakhouse.
Nice.
And what are we going to celebrate?
I guess we're kind of celebrating a bunch of things, aren't we? Because I know, like in the previous clip, I was like, I'll save the next video for saying what the final GPA or the final grades were and stuff like that, but I got straight A's.
That's what I'm celebrating.
sort of. I got an A- in partial differential equations, but still A's nonetheless.
All A's.
So that means got an A in thermal statistical physics, an A in experimental physics, an A in electromagnetism part 2, and then an A- in partial differential equations, which was supposed to be the easy class, but whatever.
And I have to say, you studied more this semester than I've ever seen you study. And I've seen you more stressed, actually, too.
I would agree with that. Yeah. What class do you think I kind of complained about the most?
Well, if you had to do anything that wasn't theoretical, then you were down.
I did complain about experimental quite a bit. Those lab reports were brutal.
I believe you said, I'm glad I never have to do another experimental physics.
Never
Report
again.
Yes.
Fingers crossed. Yeah, I made sure that I asked people, like grad students at ODU, like what classes they have to take and whether they were theorists or experimentalists. Or if they were theorists, they said that they never had to take another experimental class, which is nice. Which, in saying that, it's not a reflection on the professors at all. They were actually, both of them for both semesters were fantastic. It's just...
You've had awesome professors. ODU's been great. ODU's been great.
It really has. It was a good move.
So what next class is going to be bringing you down? What do I have to prepare myself for next?
Computational physics is probably going to be difficult just because it has a programming prereq that I haven't taken. So that's essentially saying in physics, a lot of problems that you're given, there's no clear-cut way to solve a problem, even if you know what the problem is.
I thought that's what theoretical physics was.
So theoretical physics creates the mathematical framework to describe the problem. Once you have that mathematical framework, sometimes solving the problem isn't as easy as just, you know, having a pen and paper. So in physics, what we call those kinds of equations that can't be solved on pen and paper are typically nonlinear, is what we call them. And those have to be solved numerically, meaning on a computer.
Okay.
So this computational class teaches us how to write programs in order to solve physics problems for us. And I just haven't had programming experience. I have to learn Python and Fortran for both my internship and my senior thesis, but the one that is for computational physics is in C++, which is
So you
even
have to
more
learn
different.
three
altogether.
programs. Okay.
That's right.
So you're going to be in a bad mood. Aberdeen Steakhouse. Congratulations, Drew.
Or Wendy's. Just kidding. That dinner was amazing, and now I'm uncomfortably full. And I'm going to edit this video, and then I'm probably going to pass out. I think the next video I want to make is going to be more educational. So I want to describe something or explain something. I haven't really quite decided what yet, but that's probably going to be what's coming next. So if you have any ideas, comment on what you'd like to see. And again, just thanks for watching.